Test-driven agentic behaviors is my way of evolving agent files like CLAUDE.md and SKILL.md, but doing so one test at a time. It came from trying to get Claude Code to actually follow test-driven development when writing regular code, and finding that it generally wasn't very good at it and that none of the existing skill files or tools quite got there. So I went back to the drawing board and started developing my own, and in doing so, ended up here. Now, instead of tweaking guidance and hoping for the best, I introduce one new agent behavior at a time by writing a single test that exposes what's wrong with how Claude goes about writing code, then making the smallest possible change to the agent guidance until that test passes. Of course, refactoring once that's working. Today, I'm going to show you a very basic example that illustrates a common mistake that I've seen agents and human developers make when they're doing TDD. We're going to run the test. We're going to see it fail because there's some guidance that isn't there yet. Once we see it fail, we'll make some changes to the guidance in order to get the behavior we want. Then we'll run the test again to see it pass. But before we do that, let me take you through the basic anatomy of one of these scenarios. And then while it's running, I can delve into a little bit more detail. As you will see, I'm borrowing from behavior-driven development using the given, when, then style of writing the scenarios. And the given is the initial context. And in this case, it's just a placeholder test exists at this particular location. It's just an empty dummy test that doesn't do anything. It's just to allow the agent to verify that the environment's working so that when it writes its own test, it knows that, well, when it fails, it's failing for a good reason. Then we're going on to the when step. Now, this is quite important because this is the key to making this work and trustworthy. What it does is it starts up a sub-agent. So the agent that's here right now is actually going to be acting as an orchestrator, and the sub-agent is going to perform essentially a mini coding kata. What's important about the when step is that the sub-agent is going to be provided not with a prompt, but with a path to a prompt. And that's very, very important because in the original version of this, I actually had the orchestrating agent just pass the contents of that file onto the sub-agent. Now, the sub-agent has no other context other than the prompt and whatever guidance is in the repo. Unfortunately, because I allowed the orchestrating agent to pass the content of the prompt on, it decided to be very helpful and give additional guidance on how to make the test pass, which is not what we want. We want the sub-agent to work only from the guidance that's in the repo. That prompt ends up looking like this. There's some information about how to record some evidence, some directives of what to do, and then there's some additional context limiting its scope to only the files I want it to be interested in. Then we actually get to the task where it's being asked to do this mini coding kata, which is to implement a miles to kilometers converter. So let's kick off the test. And while that's going, I'll actually explain how it evaluates the results. Now, the orchestrating agent will collect the information from what happened during that test, and then this text here is really more for our benefit. What matters to the orchestrating agent is this scorecard. Now, we have to use a scorecard because there are some things that will naturally vary, that will be non-deterministic. That might include the name of functions or variables, the order of things in ways that might not necessarily matter that much. So the scorecard allows us to have some variation. And an example I've seen is where the function signatures aren't exactly the same because the choice of function name might be different. Sometimes miles to kilometers, sometimes miles to km. It can vary from time to time. Anyway, let's just close that. I'll show you some other elements of the scenarios and how they work. But before we do that, let's just take a look at what's been happening over here. So Claude has received the instruction to run the test. It's checked the environment. I'm not sure why it's done that twice, but it's being over eager to make sure it gets things right. It then moves into the when step where it has passed on the prompt to the sub-agent. And as you can see here, it's only passed on the path to the file to execute. It hasn't passed on any additional information. And that is very, very important, as I mentioned before. Now it's just reading some documentation to make sure it understands the environment it's working in. The project that I happen to be working on happens to be in Kotlin. And as a result, the example files here are in Kotlin. But my intention is for this to work for any language. So here we've seen that it's already written to the tests. We can actually see that. Let's have a look. Make sure we refresh the environment, and then we can see that the, oops, let's do that again. And now we can see that it's added the additional scenario over here. And also it will have the first version of it. And already it's jumped ahead and implemented the entire formula, even though it doesn't have the necessary reason to do so in the test. Let's just make sure that's the latest one. It is. Okay, so let's have a look at the transcript. And here you can see that it starts out by changing this to the new scenario, converting 1 mile to kilometers. And it makes sure that it's got a meaningful test failure. So a good practice for any test-driven developer is to first write the assertion, not the implementation and the assertion at the same time. You write the assertion, you work your way backwards from there to make sure you're only creating as much as is needed to achieve the result in the test. Otherwise, you can find yourself writing a little bit more than is necessary. So I implemented that discipline by making sure that it returned a empty value. It has to compile, but an empty value. It runs the test relatively quickly, and straight away it sees that it expected 1.6 and instead got 0. The increment 2, well, this is the point at which what it should really do is just return 1.60934, but it immediately jumps to this solution here. Now, this is a problem because if you then ran mutation testing on it, if it didn't write the second test, I've told it to write the second test, so it will, but if you didn't do that, and this is what I've seen happen over and over again, when you run mutation testing, this part can be removed and the tests that are there still pass. So that leaves you with an opportunity for someone to accidentally change the implementation of your code and have no tests fail to warn them that they've affected other important behaviors in your system. So we're going to refresh this, and it has done the next step where it has written the second test that I told it to. And having completed that, it's noticed that that test passes straight away. So let's go and have a look at what the orchestrating agent found once that had that session had finished. It ran the scorecard and it has found failure here. The evidence log doesn't have enough increments, and another failure where the formula only appears after the second example forces triangulation, and we've got the failure there. And in this case, this is why we use a scorecard, because it's non-deterministic. It decided to use a slightly different format. In fact, it says no here. It says it matched exactly in this particular case, but we do allow for some variation. There is variation allowed in the scorecard itself. But the overall result is a fail. It then goes into what the 2 critical failures are, and then goes on to explain some thoughts on what we might be able to do. And then offers to iterate on the guidance in order for us to then see how we can make that test pass. So I'm not going to do that today. For the purpose of this demo, I'm just going to go back and restore some changes that I made to one of the files. In fact, I'll show you the file that I changed. This is an extension of skills. So one of the things that I found when trying to get the skill to guide the agent to work in a particular way was that the agent kind of was like, yeah, this is just guidance, I'll just do it my way. And my brother, Raymond Rodriguez, who also does a lot of work with GPTs, he tends to create custom GPTs, but more for prose-based output, not for code. He said that one of the things that he'd found quite helpful is if you get the agent to fill in a form with sort of yes/no answers, it gets it to think more about the step that it's doing. And when it actually assesses its own answers, finds that it then has to go back and redo it. Now, I didn't find that worked very well in this case, but it gave me the idea for introducing a checkpoint where it's not just about filling in the answers to those questions. It's what do you do depending on what the answer is. And in this case, if the answer is no, you have to go and recompose the code. So the increment aims to change the test result in a way that's driven by the test failure. So yeah, that's fine. Now, I expected this to result in the agent composing the code, testing it against the checkpoint, failing the checkpoint, recomposing the code, checking it against the checkpoint, realizing and iterating on that process until eventually it got it right to pass the checkpoint. However, what actually happened was as soon as the checkpoint was there, and it basically said, if you get this wrong, you have to do extra work, it then got it right first time more often than not. at one point, I think I was around 19 out of 20 times it got the code right in the first try, rather than what was happening before. It was getting it wrong an awful lot of the time. And this was odd to me because I thought, well, surely then I don't need the checkpoint. As soon as I removed the checkpoint, it started getting it wrong. I was like, okay, this is weird. So I started having a conversation with Claude, and it said to me that agents are lazy. As soon as they realize they may have to do extra work, they find ways of avoiding that. So if it gets the code wrong, the code that it composes before it does the write, if it gets it wrong in a way that it knows it will fail the checkpoint, it doesn't bother getting it wrong, it just gets it right. So the checkpoints aren't there to actually check anything. The checkpoint is there to tell the agent that it may have to do extra work if it doesn't get it right, so you might as well just get it right. This is the guidance that I actually removed in order to force this failure, and that is that the proposed change is not overstepping, and there's a number of questions it has to answer, and if yes to all three, then use the literal instead. So let's just undo that change, rerun the test exactly as is, now with the new guidance, and we should see a different result. Now, while it's kicking off doing that, I'll show you a couple of other things that I think are worth mentioning. The anatomy of these tests is made up of a number of different types of entities. We have prompts, which I showed you in that content there. We have reference files. So for this, there is a reference document that it does compare to, and those are just example code files. In this case, we have the test. This is an example of what the test ought to look like when it's done. Not exactly, but close enough. And that's why we have the variation on the scorecard. And then for the actual implementation, this is a reference for what the implementation should look like roughly. And again, there can be some variation on it. It might choose different names for things and so on, but the fundamentals should always be the same. So the scorecard can do some fuzzy matching that is reliable and repeatable, despite the fact that it's a non-deterministic result. And now what it's doing is delegating off to the subagent again. This time the subagent, because I've changed the guidance in the repository, in the agent guidance files, it should now actually pick up on that and do things in the right way. Now, normally I wouldn't have had a pre-prepared change. Normally I'd end up having a conversation with Claude. And what I've noticed with that is, because I've spent a lot of time coaching teams in various technical practices that increase throughput of software development, I found that those same skills were really useful with Claude. Because rather than telling it what change I want to make, or rather than just making the change, what I'd do is I'd ask it questions to help it articulate back to me what it thinks the right thing to do is, what it thinks the right behavior is. And then while it's articulating it back to me in terms of what it thinks it ought to do, I then help it to better understand it by challenging its response and asking it more questions until eventually it can play back to me, it's supposed to work like this. And I'm saying, yes, that is correct. And based on that, it then proposes changes to the guidance documents, whether that's a skill file, Agents.md or CLAUDE.md, or one of the checkpoints, in order to then affect the behavior we really want. So I'm essentially helping it to understand. I know LLMs don't technically understand, but helping it to understand and frame the behavior in a way that makes sense to it in some way. And as a result of that, it's then able to make changes to the agent files, which usually within 1 or 2, rarely 3 iterations of making the change and running the test, do we actually get it to do the things that we want. And then when it's done, I also have a suite of tests which cover off all of the tests that I've got so far. And obviously there's more work to be done here, but it covers off all the scenarios so far. So once I've made those changes and seen the test pass, there's a couple of things that I do. One, I actually rerun that test in a loop. So it runs 5 times over to make sure that there's no sort of subtle variations that emerge. And usually 5 times is enough to reveal it. Occasionally I've had to do it 10 times, but most of the time, 5 loops of that test to see them pass every time is enough to verify that the guidance is strong and is holding. And then the second thing I do is run this suite of tests once, just to make sure that there's no regressions. And once that's happened, I then commit the changes and can go back to actually doing the software development work that I was doing previously. Now, one of the big challenges with this is it is a little bit on the slow side. However, I have already done a lot of work to speed it up. It's already 50% faster than it was when I first started working with this process. And there's a number of additional strategies that I can use, in particular context compacting for the specific test at a time, in order to make that initial warm-up period happen a lot more quickly. There's a couple of duplicate steps in here as well, where it's the orchestrating agent is running the Gradle test, and then the subagent is doing the same thing again. Well, I'm going to remove that duplication as well. I actually started that process, but believe it or not, it's not as easy as you'd think. So before we wrap up, let's just see how that worked out in the tests. Right, here we go. We've got the evidence file here, and increment 1 is largely as we expected, except it's done something interesting. It's put the implementation in the test file to begin with. That's a perfectly valid approach. But again, it's just giving a dummy value so it can see that the assertion is failing for the right reasons. It's failing because it's getting the wrong answer, in this case, 0. Now, let's move on. It's now going to move to increment 2, where it's going to try and make the first test green, and it's just going to use a hard-coded value of 1.6. Now, previously, it just implemented the whole formula. This time, it has done the right thing and returned only what the test demanded. Saw that pass and moved on to writing the second failing test, which in this particular case results in it providing a 2 and getting a 3.1868 as the answer. It will, of course, see that fail, which you can see the assertion failure here, and then moves on to the fourth increment, which is to make that test pass. And the simplest thing that can possibly work in this case is that it implements the formula. Perfect. That is exactly the way you're supposed to do TDD. And that results in you having much better test coverage as a side effect of going through this process. And because, of course, it put the function in the test, it decided that it was going to move the function out of the test into its main file, which is what it's done here. Before, the function did not exist, and now it's created the function in a file called distance conversion, and then also remove the function from the test file, and of course, running the tests again to see it pass. So there you go. Red, green, refactor. Leave a comment, even if you just thought it was interesting. Tell me some thoughts that you might have about things that I could do that would improve it, apart from making it faster. I know that much already. And if you think what I've been doing here is a good thing, then make sure you let others know too. Hopefully I'll see you in the next video where I'll show you the refactoring test. But until then, bye-bye.